Okay, going to be working the homework solutions here for section 3.1 functions. We've got our first problem here. Oops, I need to open up the program. Give me just a second. We did a problem like this in class. We may have actually done this problem exactly, but I'll go ahead and work through it. So let me take this to a new page here. You know what? Let's see, homework solution. Sorry, I should have had this ready to go here. 3.1. There we go. Where's my other one? All right. Okay, so here we go. So here's the function they're giving us, and we're asked to evaluate the function at these values. So for part A, all we're going to do is plug 0 into the function. So we replace all the x's with zeros. Of course, these go away because of 0, and so we get -2. For B, we plug in 5 to the function. So 3 times 5 squared plus 3 times 5 minus 2. Okay, so we have to do the 5 squared first. That's 25. 25 times the 3 gives us 75. And then we're going to add to that 3 times 5, which is 15. And then subtract from that 2. So 75 and 15, that's 80, that's 90. And then take away 2, we should get 88. Okay, and then for part C, we want to plug in -5. So it's important here to know that this -5 is going to be squared. And then here 3 times -5 and then -2. So we have to square -5 first. So -5 times -5 is 25. Then multiply times 3, we get 75. And then here 3 times -5 is -15 and then -2. So 75, take away 15, we get 60, and then take 2 more away, we should get 58. Okay, and then D is where we start to do plugging in algebraic expressions. So what is f of -x? Well, we replace all the x's with -x's. And then very important, when we square -x, that's the same as doing -x times -x, and negative times negative should always be positive. So we'll get positive x squared. So we get 3x squared. And then 3 times -x gives us -3x. And then we have -2, and that's it. That's our algebraic expression. E, we want negative f of x, which means we're just going to take a negative and throw it in front of the function. And then distribute the negative through, which changes the signs of everything. That. All right, and then let's see, f, we're going to plug in x plus 3. So when we plug in x plus 3, we replace the x with x plus 3, so we have to square it. Then add to it 3 times, again, replace the x with x plus 3, and then -2. So this is 3, and then I have to go square this, right? Which means I have to do x plus 3 times x plus 3, and then I have to FOIL this. Okay, so when I do that, I'm not going to show the work. I should get x squared plus 6x plus 9. And I'm putting in parentheses because this 3 is still going to have to distribute through. And on this, on the second one, I'm going to just go ahead and distribute the 3 through now. And then we still have the -2 at the end. So now distribute the 3 through, 3x squared plus 18x plus 27 plus 3x plus 9 -2. So we get 3x squared, collect like terms, I have 18x and 3x, that's going to be 21x. And then 27 take away 2, I should get plus 25. There we go. And let's see. For part G, I'm going to plug in 4x. So I get 3 times 4x squared plus 3 times 4x minus 2. Here, when I square the 4x, I'll get 16 because I square the 4, and then I'll square the x and get x squared. plus, I'll just multiply the 3 times 4 there, get 12x minus 2. And then multiply 3 times 16 to get 48x squared, then plus 12x minus 2. Can't do anything to that. And the last one, h. So we plug in x plus h into the function. This is the one I said is very important to be able to do this. So we plug in, we replace the x with x plus h. Everywhere we see an x, there's an x plus h. I have to square this, which again, I would do that on the side and FOIL it out. If you do that, you should get x squared plus 2xh plus h squared. Distribute to 3 plus 3x plus 3h and then minus 2. And finally, distribute the 3 through the parentheses in the front there. And we should have a final expression. There are no like terms there. We can't put anything together. So that's our final answer. All right, let me move this out of the way and then let me type these answers in to see how we do here. So we get -2. Okay, for this one, we had got 88. For this one, we had 58. For this one, we had negative x. When we plugged in negative x, we got 3x squared minus 3x minus 2. And then this one, we got negative 3x squared minus 3x plus 2. For this one, we got 3x squared plus 21x plus 25. Oh, whoa, what happened? Where did I mess up? Oh, that's 22, oops. No, that's 21, what the hell? 3, 9. Hold on a second. 3x squared, I'm looking back at this work right here. I plugged in x plus 3, we squared it, that's x squared plus 6x plus 9, distribute 3x squared, 18x, 27, then distribute through here, we get 3x plus 9 minus 2. Oh, I know what I did. Oh, darn me. I need to put this, and this together. Oops. Okay, so we go 27 plus 9 is 36, and then take away 2, this should be 34. Yeah. Okay, glad that it gives me another chance. What the heck? What am I doing wrong? Doing something wrong. 27 and 9, that's 36. 34x. Oh my God. And it's too early in the morning, I think. I know you're sitting there going, "God, this guy's stupid." Okay, 21 is still 21. Sorry, it's this number here that becomes 34. My gosh. 21, 34. Okay, there we go. Finally, I need to wake up, finish this coffee. All right, the next one here is 48x squared, oops, x 48x squared plus 12x minus 2. And the last one is 3x squared plus 6xh plus 3h squared plus 3x plus 3h minus 2. There we go. All right. Okay, now I'm going to look real quick. I think I did this problem in class. So let me bring up the notes because I don't want to go through that entire problem again. Notes from yesterday, we started class. That's slightly different. Okay, it's a slightly different problem. So yeah, I guess I'll do it. That's what I'm here for. So homework solutions, new page. Go get the problem. All right, here we go. So first we plug in 0, right? Part A, plug in 0, place all the x's with zeros. If we do that, we get 5 over -6. It just kills off these two terms. If we plug in 1, we should get 2 times 1 plus 5 over 7 times 1 minus 6. So on the top, we get 2 plus 5 is 7. On the bottom, 7 minus 6 is 1. So our answer should just be 7. For part C, we're plugging in -1. So we get 2 times -1 plus 5, and then 7 times -1 minus 6. So this is -2 plus 5 is going to be 3. On the bottom, we get -7, take away 6 more, that should give us -13. Okay, part D, f of -x, we're plugging in variable expressions. I'll do it in blue. Okay, so f of -x becomes 2 times -x plus 5 over 7 times -x minus 6. So when I multiply here to here, I get -2x plus 5. And on the bottom, when I multiply here to here, I get -7x minus 6. Okay, E, I want -f of x. So that means I'm just going to throw a negative in front of this function. And I discussed in class that you can leave the negative out there, or you can put it up top, distribute it through, or you can put it in the bottom and distribute it through. I'm just going to leave it out here, and then we'll see when I type it in how things go. Okay, so that's E. Look at F. So for F, we want to plug in x plus 2. So this is going to be 2 times x plus 2 plus 5, and then 7 times x plus 2 minus 6. Distribute the 2, 2x plus 4 plus 5, and then 7x plus 14, and then, yeah, it's distributing through here, and then minus 6. So on the top, we get 2x plus 9. On the bottom, we get 7x. Take 6 away from that, we should get 8. Okay, G. So we want to plug in 3x now. So if I plug in 3x, I get 2 times 3x plus 5, and then 7 times 3x minus 6. Okay, multiply there, we get 6x, and then the plus 5. And then multiply here, we get 21x minus 6, and that's it. Okay, last one. If we do x plus h plugged in, we get 2 times the x plus h plus 5, and then over the 7 times x plus h minus 6, distribute. So we get 2x plus 2h plus 5, and then over, distribute the 7, 7x plus 7h minus 6. There we go. All right, let me go check these. So our first answer here, oh, where'd it go? And where'd it go? Oh, there it is. Okay. So our first answer here was 5 divided by -6. The next answer is 7. Next answer was 3 over -13. Okay, f of -x is negative. Let me do it this way. I'm going to put the fraction in like that. I'm going to put -2x plus 5, and then hit the down arrow, and then hit -7x minus 6. Okay, for the next one, I'm going to see how it does with this one. I'm going to put negative, and then I'm going to put a fraction, Then I'm just going to type in the original function. So 2x plus 5, down arrow, 7x minus 6. So I'm putting that negative just out in the front. This one, f of x plus 2, that was part f. That, again, was a fraction. It was 2x plus 9 over 7x plus 8. And this one turned out to be, again, a fraction. It was 6x plus 5 over 21x minus 6. And the last one was a fraction, 2x plus 2h plus 5 over 7x plus 7h minus 6. There we go. Okay. What is the domain of this function? Well, there are no problems with this function, right? There's no division, there's no square roots. So the domain of this should be all real numbers. They want us to type in interval notation. So I'm going to put here an interval like this. And then I'm going to put in here negative, and then here's the infinity symbol. And then here I will put in positive infinity. That's it. All right, so this one, the only way that we can have a problem here is if this thing here is 0. So I have to ask myself, is this ever 0? We don't want it to be 0, right? We don't want that to be 0. So we ask ourselves, when is it 0? And if you move the 7 over to the other side, makes it -7, and divide by 9, I think it's clear to see that there's no way we're ever going to be able to square a number and get a negative number, not a real number. So this is never going to happen, which is good. That means that any x we plug in will work. So my answer should again be all real numbers. So negative infinity to infinity. Okay. Now in this one, we have a fraction. And so again, I need to look at this and I need to ask myself, you know, is this ever 0? So I want to make sure that this thing is not 0, right? It's what we want. So I ask myself, when is it 0? And I can factor the left side as a difference of squares. And then I can set each of those equal to 0 and I get 2 answers, 5 and -5, or -5 and 5. These are the 2 places I do not want to include in my answer. So on a number line, that means I don't want -5, I don't want 5, but I want everything to the left, everything in between, and everything to the right. So as an interval, here's the way I do this. I'm going to go, the first section will be, where is it? I don't have it here. I guess I'll just have to type a parenthesis, and then negative infinity, all the way up to -5. And then I will union that with another parenthesis, everything between -5 and 5. So -5, comma 5. And then another union, now everything past 5. So parenthesis, comma, I'm sorry, 5, comma, infinity, and close it. See how it does with that. All right. All right, so we look at this one and we say, all right, do we ever have a problem? Is this ever 0, right? We just want to make sure that this is not 0. So we look at when it is, and we'll throw these answers out. So when I look at that, I can factor the left side by pulling a GCF, pull an x out of both, and then I set each of these factors equal to 0. And this one is just x is 0, so that's going to be a problem. And this one has no solution for the same reason as the previous one. If we move the 2 to the other side, there's no way we can square a number and get negative. So the only answer we'll have is 0. So we want to make sure that we are not including 0. Everything to the left is fine. Everything to the right is fine, just not 0. So the way I do that in interval notation is I say negative infinity, comma, all the way to 0, parenthesis, union, everything from 0 to infinity. All right, next one. So now we have a square root function. And so what we need to make sure is that the 5x minus 20 is always greater than or equal to 0, because I cannot have a negative underneath there. So this is what we want. This is a linear inequality. So all we have to do is add 20 to both sides and then divide by 5. So if you divide by 5, you get 4. One thing I will point out is that with inequalities, you have to be careful. If you ever multiply or divide both sides of the inequality by a negative number, you have to flip the inequality over. So for example, let's just say we had this. This is not what we have, but let's just say we had this. And I move the 20 to the other side. And now I divide both sides by -5. When I divide both sides by -5, what will happen is, I'll get x on the left, I'll get -4 on the right, but this has to flip and become this. Okay, just keep that in mind. It's only when you multiply or divide by a negative number on an inequality that you have to do that. Now, in our case, we just have everything bigger than or equal to 4. So it's everything from 4 on, but also including 4, right? So that means when I put my answer in, I'm going to have to use a bracket. So I'm going to do bracket 4, comma, to infinity. That's everything bigger than 4 and including 4. All right, next one. All right, so this one's a little tricky. We have a couple things going on here. First of all, we need that the x minus 5 cannot be equal to 0, right? Because if that's 0, then we have division by 0. In other words, x, if we check when is that 0, then we get x is 5. So we don't want that in our answer, right? We want to make sure 5 is not plugged in. The other thing we have is a square root. So we need to make sure that 2 over x minus 5 is bigger than or equal to 0. Because, again, what's underneath this root cannot be negative. So we need this to be true. Now, this is called a rational inequality, and these are a little bit tricky. I actually didn't do one of these in class. What you do is you do it kind of like the quadratic inequality we did in class. We're going to set it equal to 0 first, okay? And then when we look at this, we ask ourselves, how do you solve this, right? So when is this thing going to be equal to 0? Now, the problem that we run into is that we try and clear the fractions by multiplying both sides by x minus 5, and what you get is these cancel, we get 2. On the right, we get 0, and 2 is never equal to 0. So what does that mean? That tells us that this expression here on the left can never be 0, right? It's never going to be 0. So if it's never 0, it's either going to be, positive or negative, right? So the next thing we do is we look at any places where we have a problem. So we know that at 5 we have a problem, right? We knew that from over here. So what you do is you draw a number line and you put 5 here, kind of like we did with the quadratic inequality. And then you pick 2 test points. So let me pick 0 and let me pick 7. And what you do is just test these into the original inequality right here. So if you plug 0 into this, you'll get 2 over 0 minus 5. And you're asking yourself, is that bigger than or equal to 0? And that is not, because that's 2 over -5. That's a negative number. That is not bigger than or equal to 0. So that means none of the solutions are here. If we try 7, this is bigger than 0 because you get 2 over 2 is bigger than or equal to 0 because that's 1. So that means everything over here works. Okay, so let's put this all together. In order for this function to be defined, first thing we have is that x actually cannot be 5. So on a number line, here's 5. We cannot have 5, right? And then this part over here says, okay, anything bigger than 5 works. So we want everything over here like this. So that just means, 5 to infinity. Now, they want this in here. They say type an inequality for this. Okay, so they didn't want interval notation. They want set notation. So all I'm going to say is it's all the x such that x is bigger than, strictly bigger than 5. And that's it. One more. One more? I don't know what problem I'm on. Oh no, I've got a long way to go, I think. Clear this out. Okay, so the domain of this one. So the domain of this, again, we're going to look at the denominator. We're going to tell ourselves, hey, look, this x minus 2 can't be 0, also we'll get division by 0. The other thing we know is the x minus 2 has to be greater than 0 because it can't be negative. So if x is 2, we have a problem, right? Because we'll get division by 0. And then this inequality, you just move the 2 to the other side and you get x is greater than 2. So we don't want x to be 2, but we want it to be greater than 2. So the domain here should be everything bigger than 2, not including 2. So I'll put 2 to infinity. Okay, I'm going to have to cut this short, so I'm going to have to do a second part to this video. This will just be the first part. There will be a second part to come soon.